Good morning, children. So yesterday in our class we finished the introductory part of chi-square test. Okay. Now let us move on to that problem section of chi-square, that part 2. Okay. So second part of the chi-square test. You know why this is practicing and why we are going to test this. The main aim is it is a test of goodness of fit. That means this is a very old concept developed by Carl Pearson in 1900, and a good of fit that leads to acceptance of null hypothesis. Okay, our observed frequencies differ considerably from expected frequency. Chi-square value will be large, and then fit is poor. Clear? Observed frequency differ considerably from expected frequency. Chi-square value is large and the fit is poor. Okay. Therefore, a good fit leads to acceptance of null hypothesis. Okay. What is a good fit? If observed frequencies are close to the expected frequency. If observed frequency are close to expected frequency, that is good fit. Otherwise, it is a poor fit. Understood? So, we have to first construct a null hypothesis. You know what is null hypothesis? We studied this null hypothesis and alternate hypothesis. Okay. So, in null hypothesis, what we assume is there is no significant difference between observed and theoretical value. Clear? There is no significant difference between observed and theoretical value. That is null hypothesis. Okay. The chi-square value may be less than tabulated value at a certain degree of level of significance. Or chi-square value may be greater than the tabulated value. So, whatever it may, you have to reach in a conclusion. Okay. So, that is the basic thing regarding chi-square test. So, now let us move on to problems. Usually, we are doing problem from Mendelian experiments, and we can practice the goodness of fit by using monohybrid cross and a test cross. Okay. So, now I am going to give you an problem, and now you can read it and we can do this problem. Okay. So, look into that question. In F2 generation, Mendel obtained 621 tall plants and 187 dwarf plants. So, I will write here 621 tall plants and 187 dwarf plants. Clear? Okay. And the total of 808 plants. Clear? And test whether, question is test whether these two types of plants are in accordance with Mendelian monohybrid ratio. What is Mendelian monohybrid ratio? That is 3:1. Okay. So, test whether these two types are in accordance with Mendelian monohybrid ratio 3:1. That's our question. Okay. So, just read once more. In F2 generation, what we obtained is tall plants 621, dwarf plants 187, total 808. This is our observed frequency. What is the ratio? You know, Mendelian monohybrid ratio 3:1. Clear? Okay. So, this is the question. So, let us see how you can do this experiment. So, I hope you all of you written the question in your notebook. Clear? Okay. Now, let us do this. So, for that you have to draw a tabular column first. Okay. So, how you will draw the tabular column? And before that you have to find out these expected frequency. You know what is observed frequency? Now you have to find out expected frequency. Okay. How you will find out expected frequency? You know this is in the ratio 3:1. That is a total of 4. Out of 4, 3 tall, out of 4, 1 dwarf. That is the meaning 3:1. So, here you know the total is 808. So, you can write the expected frequency of tall plants. How you will write expected frequency of tall plants? That is 3 by 4 into total is 808. 3 by 4 into 808. That answer is 606. Clear? This is the expected frequency of tall plants. Clear? Okay. Because dwarf from 4, 3 is dwarf. Okay. So, from expected, based on the ratio, how much tall plants you have to obtain from your in your experiment? 606. From based on the actual ratio, you should get 606 tall plants. Understood? Okay. Now, let us see how these dwarf plants will arise. That is 1 by 4 into 808. 1 by 4 into 808. How much it is? It is 202. Clear? So, the ratio of that expected frequency of dwarf is 202. Expected frequency of that tall is, you got how much it is? 606. Expected frequency of dwarf is 202. Understood? Okay. Now, so we have now the data that from our hand we have observed frequency and expected frequency. Observed frequency of tall plants is 621, that is given in the question. Expected frequency of tall plants is 606. 606. Understood? Then observed frequency of dwarf is 187 given in the question. Expected frequency of dwarf is 208. Okay. So these are the figures with your hand now. Clear? So from the question, observed frequency is given. Based on the ratio, we found out expected frequency. Now these are the values in your hand. Now next step is you have to draw a tabular column. How you will draw the tabular column? See, you have to draw the tabular column like this. What are the title required? Then here tall plants, then dwarf plants and total. Okay. From here also 3 columns required. 1, 2, 3 columns required. Okay. So see, observed frequency. What is the observed frequency? This is tall, this is dwarf. Clear? And this is total. Understood? Tall, dwarf, total. Now what is here? Observed frequency, FO. Here expected frequency, FE. Observed frequency of tall is 621. From the question you know. Expected frequency of tall we found out. How much? 606. Then observed frequency of dwarf, you know what it is? 187. Now expected frequency of dwarf we find out, that is 202. Clear? Now total. Its total is 808. By adding this also you will get 808. Understood? Okay. Now next step is you have to find out deviation. The equation, now you have to remember the equation. What is the equation? Sigma FO minus FE whole square divided by FE. Understood? So you have to find out the difference FO minus FE. So here it is FO minus FE. 621 minus 606, how much it is? 15. 187 minus 202, you will get negative answer, that is minus 15. Clear? So this is the answer. So from this tabular column you got the FO minus FE for tall and dwarf. For tall and dwarf separately. 15 and minus 15. Clear? So display all the values in the tabular column. This is the way you have to do it. Okay? Clear? Now next step is applying the equation. You know what is that equation. Once more I will write here. X square equal to sigma, in bracket you can write FO minus FE whole square divided by FE. This is a equation. Understood? So now from that question, our figures, F4 minus Fe, for there are two parts, F4 minus Fe. For tall it is 15 and dwarf it is minus 15. So you have to write like this, because this is a total sigma for all this. So you have to split it like this. F4 minus Fe, F4 whole square divided by Fe minus Fe whole square divided by Fe, like this. See, F4 square divided by Fe minus plus adding Fe whole square divided by Fe. So you have to split this like this, because sigma, adding these together, total sigma, so you have to split like this. Now you put the value here. How that value? First one is 15 square divided by the total 606, plus second one is answer minus 15. So take care, minus 15 whole square divided by 202, observed frequency. Okay. So 15 square, what is it? 225. Clear? Divided by 606 plus minus 15, again what? 225 divided by 202. Okay. While doing this, you will get that answer. That answer is 1.4852. Answer is 1.4852. Okay, 1.4852 is the answer. So what is that? It is the x square. So answer is 1.4852. That is x square or chi square. Clear? Okay. So how you did it? Observed frequency is given, expected frequency you found out, deviation F4 minus Fe you found out. Now applied in the equation, so split that, because the sigma is for all. So 15 square by 606 plus minus 15 whole square by 202. Then adding together you will get the answer 1.4852. Clear? Okay. Now our next step is how you will interpret the answer. So calculated x square value, what is calculated x square value is 1.4852 is the calculated x square value. Okay. So now I already told you there are chi square value, tabulated value, that is there in the last pages of the Clark's table. So just look into that. You can see that degrees of freedom. You have to find out degrees of freedom. Here degrees of freedom is find out by taking the phenotypes. How many phenotypes are there? Tall and dwarf. So degree of freedom is n minus 1. You know that. So 2 minus 1 degree of freedom is 1. Clear? So now we already know, usually we are taking the level of significance as 5%, that is 0.05, to reduce the error. So look into the table. You can see there is that level of significance 0.05 horizontally on the upper side, then 0.05 down, degree of freedom vertically, and take the degree of freedom 1, then in that column. So it is like this tabular column like this. Okay, here you can see the level of significance on this side, here degree of freedom. So degree of freedom 1, 2, 3, 4 like this written. Here that level of significance, to take 0.05, if it is 0.05 from this the value like this. So this is the value. Now find out this value for 0.05 level of significance, degree of freedom 1. So what is this value? So here for this question, this value you have to find out the value, that is 3.84. This value is, tabulated value is 3.84. Clear? Our calculated value is 1.4852. Okay. So how you will describe it? The calculated value is less than the tabulated value. 3.84 is more. Calculated value is less than the tabulated value. Clear? So what is the result? So you can see the difference between observed and expected frequency is not significant. We already described that. When calculated value less than tabulated value, the difference is not significant. That means The difference between observed and expected frequency is not significant. So the null hypothesis is true. What is our null hypothesis? What you written in the null hypothesis? Tall and dwarf plants are segregating in 3:1 ratio. What is there given in the question? That is a null hypothesis. Mendelian monohybrid ratio 3:1. Or that in accordance with the 3:1. That is a question. So your null hypothesis is also that. That is tall and dwarf segregating in 3:1 ratio. That is the null hypothesis. What is the null hypothesis? Tall and dwarf. See, null hypothesis H0. Tall and dwarf segregate in 3:1 ratio. That is the null hypothesis. Okay. Now, calculated x square value is less than tabulated value. Calculated x square value is less than tabulated value. Means, what is the meaning? Observed and expected frequency. The difference is not significant. Difference is not significant. So, null hypothesis is true. So, our null hypothesis is true. Means, this is in accordance with the Mendelian monohybrid ratio. Null hypothesis is true. Clear? So, while at the last paragraph, you have to write like this. Clear? So, this is the answer to that particular question. Okay. Now, let us move on to another question. Just a minute, I will give you the question. Yes. This is that question. Read it. In a Mendelian experiment on breeding, 4 types of plants are expected to occur in proportion of 9:3:1. See, 9:3:1. 4 plants. Okay. Observed frequencies are 891 round yellow. Clear? 316 wrinkled yellow. Clear? Then 119 wrinkled and green. Wrinkled green. And one more I left. 290 round and green. Okay. Before that you can write 290 round green. Okay. So what are the 891 round yellow, 316 wrinkled yellow, then 290 round green, 1119 wrinkled green. See, these are the 4 observations in that question. Okay. Now, find the chi-square value and determine the correspondence between theory and experiment. That is the question. Find chi-square value and examine the correspondence between theory and explain. Clear? Okay. So, this is the question. Now, how you will do this? So, in the last question, we did monohybrid cross. But here, this is a dihybrid cross. So, there are some small changes in the tabular column. So, in the tabular column, on one side, you need 5 columns. For that, like this, draw. This is for the phenotype, and this is for round yellow, this is for wrinkled yellow, this is for round green, this is for wrinkled green, and total. So, I will write here round yellow, wrinkled yellow, round green, wrinkled green. See? Okay. So, observed frequency of F0 and expected frequency. This side 2 column, F0 and Fe. You have to write like this. Clear? Okay. Now, how you will find out this Fe, expected frequency? Because these are all 9:3:3:1. That is total 16. So, how you will find out this total from total 16? One I will show you. For round yellow, the observed value is here given. We have to find out expected value. So, total you have to calculate. So, here you write 891, then here 316, then here 290, then here 119, So while adding you will get a 1616. This is the total 1616. Okay, so total 1616. So find outing that first one I will show you how to find out. That is round LO. For calculating round LO, round LO is the dominant one, 9. 9 is to 3 is to 3 is to 1. In that it is given. So round LO, how we will calculate it is 9 divided by 16. Okay, 9 divided by 16. Okay, yeah, then into 1616. 9 divided by 16 into 1616. That is the answer, 909. 909. Okay, so you have to write here expected frequency 909. So likewise second one, how you will find out 3 divided by 16 into 1616. That is 303. Okay, again third one also 3 divided by 16 into 1616. That is again 303. Last one 1 divided by 16 into 1616. That is 101. Likewise fill all these. Then what you did in the last question, same way here, F4 minus FE. So minus 891 minus 901, 9, you will get a minus 18. Likewise do all. Then same way you have to add. That I will do. So F4 minus FE, first one is F4 minus FE whole square by FE minus 18 whole square divided by 909 plus second one is you will get 13 square divided by 909 plus next one you will get minus 13 square divided by minus 13 square divided by 901 plus next one more is the 18 square divided by 101. Okay, this way. Now you will get again that answer. Here the answer is chi-square is equal to 4.6799. Then tabulated value for that percentage of 5% level is 7.80. That is tabulated value. And one more thing you have to remember here. Here how many phenotypes are there? 4. So n minus 1, that is 4 minus 1. 3 is the degree of freedom. So what is the degree of freedom? 3. So you have to check degree of freedom 3, percentage 0.05 level of significance. The tabulated value is 7.80 and then calculated value 4.6. Here again that calculated value is less than tabulated value. So the difference between observed and expected frequency is not significant. Okay. So here also we can accept a null hypothesis. So what is our null hypothesis? H0 is theoretical value corresponds to experimental value. What is the question? Right way, same way you can write. Okay. So this is how we will do these problems related to chi-square test. Okay. So these two problems you have to write in your record sheet also, and I will give some more questions that I will post in your group and we can do it. Okay. So I hope you understood well. So practice and do. Okay. So have a nice day. Thank you.